Good morning, students. This is Prakash, and in class 10th physics, we are going to study about the very important laws, which is very important for your understanding and also for your board exam. As you know that when the current flows in the electric circuits, it follows some laws like that. First one is Ohm's law and other one is Kirchhoff current law. Like, there are these are laws on the basis of current flows and controlled according to these and can be explained as above. Now, as we know that when we apply the potential difference across any conductor, then there is a current flows from positive plate to the negative plate. Let us see this picture. In this picture, we can say that there are a conductor having length L, a conductor AB having length L, and when we connect, and it suppose that its area of cross section is capital A, and you know A equal to pi r square. Actually, this is the area of the cross section of the conductor. Okay, so as when we connected this conductor AB across the two terminals of this cell having potential V, and throw a key. As we on this key, then the current flows from positive plate to the negative, from positive plate to the negative in such a way. And like that, and after that it current passing through the conductor and again comes back into the cell. So what we observed that there is a relation between the current and voltage. This current and voltage, there is a relation, and also this conductor has a resistance to pass the electricity. This is the resistance of the conductor, like we can write it capital R. So this is the resistance, and there is a current flow I and potential of the cell V. We have three things: electric current, potential difference across the conductor, and resistance of the conductor. Resistance is nothing but it is only the characteristic property of the material which resists the flow of electric current, and we see it in next lecture clearly. Okay, for this let us see the statement of Ohm's law. What is the statement of Ohm's law? Ohm's stated that at a constant temperature, actually there should be no variation in the temperature of the conductor. Okay, so at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its end. Actually, we have a conductor like that, and there is a difference between the potential difference. Actually, this end has B1, this has B2, and B2 minus B1 is known as simply B, and this B is called potential difference. So I hope you understand this. So we can say the potential difference across the ends of a conductor is directly proportional to the strength of current, or we can say strength of the current flowing through the circuit is directly proportional to the strength of the potential difference. It means if there are stronger potential difference applied, then the current will be much greater. If we applied less potential difference across the ends of the conductor, then there will be less amount of current that is flowing through the electric circuit. So So this is the statement we have understand. Now after that, let us prove it. Let us see its proof. Let a conductor having length small l and resistance r, having length small l and resistance r, as we applied potential difference and press key on, then there is a flow of the current through the circuit, and this potential and current related as according to Ohm's law. I is proportional to V and at a constant temperature. Keep in mind, if temperature change, then you can't examine real values. So take care, always kept temperature constant while during the experiment. Ohm's law. Okay, so we can write V proportional to I or I proportional to V. Both are directly related. It means if one quantity increases, then there is also increase in the second quantity. So in this way, on removing proportionality constant, we can write V equal to I R, or V equal to Ri. So this is the known as Ohm's law. This is very famous and this is called the Ohm's law. So I hope you understand this and you remember it, and it is very important for solve numericals, and also its experiment is also very important. You note in your notebook and learn and see previous year question papers. This is very important. I repeating again. So in this relation, what is R? What do you mean by this R? This R is the constant. This is the constant at a constant temperature, and also known as resistance of the conductor. This is known as resistance of the conductor. Okay, and this resistance depends. Uh, depends like nature of the material, length of the conductor, and area of cross section of the conductor, also temperature of the conductor. So in this way we can say R is R actually rho L upon A. It means R is a resistance. It is related as R equal to rho. You can call it rho, simply rho, like that. So this is the formula. I for this explanation I give next video you. So now see only its other forms, like first form is B upon I equal to R. This is first form. Second form, B upon R equal to I, and third form you know very well, V equal to IR. So these are the three forms of Ohm's law. In this way you can write to when we needed find out resistance, and then put up the value current and voltage. If we want to calculate current through circuit, then put up the value of these, and if we want the value find out the value of voltage, then multiply current multiply by the resistance. If there are any two values given, then third values can be find out very easily. So in this way you can notice that the current is directly proportional to the potential difference, and inversely proportional to the 1 upon resistance. So in this way you can write here that I proportional to V and I inversely proportional to 1 upon R. So this is the Ohm's law. You can solve numerical with these formulas, and you have note in your notebook and learn it. I hope you understand. So for must reply to us that you have understand. Okay, if any confusion in your mind, then write in on your paper and send me. Okay, I will provide you solution. Thank you. And next lecture we will see its other factor like resistance and then numericals. Thank you very much.